Okay, hello everyone. I'm back with another YouTube gaming video. I'm just kidding. So here's the struct that I was talking about. These are all the variables. A structure or a type def struct is just something that contains multiple variables under one name definition. This is the main function. This is where all the code's gonna fucking load. I'm probably gonna have what is it? Wait. I think it's wait. No, hang on. No, it's not wait. Okay, so I'm gonna have a loop here. I'll learn how to define that later. I know nothing about the C programming language. I just know how to make simple shit using it. Actually, here, let me show you this how to do this. This is a pretty cool thing. Okay, so I'm assuming that as I go through implementing these simple programs, eventually I will hit a point where I am starting to make more intellectual videos. Right, like I said, I'm quite inebriated right now. I had like over 200 milliliters of alcohol. Don't tell anyone. But from here on out, I'm probably going to create stupid fucking retard videos that will eventually evolve into videos that are consistent and are and bore consistency or sophistication. Fucking retard. You already said consistent. Okay, so we have the int main function. We have the variables. Well, first we have to so in the other program I made, here, let me show you it. This is just a shortcut so I can get out of here without, oh, yeah, okay, there you go. So I can get out of here and, do something cooler. Okay, oh, yeah, okay. So this is the later implementation, or the earlier implementation of the 6502 CPU that I was using to emulate the Nintendo Entertainment System. This is the type def enum. It's not a struct. It's implied why it's not a struct. This is the carry. This is the 0. This is the implicit. This is the I think it's decimal. No. This is negative. These are all of the CPU flags. That they don't necessarily need to be called, but for setting a flag, you'd usually set a flag and watch its every move throughout your program. That's necessary for many reasons. It allows you to debug your code more with more precision and sophistication. So that's one upside. It also gives you an idea of where, like I said, it allows you to debug the code more efficiently. And a part of the reason why it allows you to debug the code efficiently is because it gives you, the state where the flag is being set, right? So the flag is basically an 8-bit variable, like most things in the 6502 CPU. Most things are 8-bit because it is an 8-bit processor. It does load from 16-bit memory, though. It loads all of its values from 16-bit memory, and 8-bit values are able to manipulate 16-bit memory using what are called opcodes. These are operational variables that allow you to modify data. They allow you to manipulate the data. This right here is a switch. This allows you to call certain opcodes for each case. These opcodes are implemented based on the case, and afterward you break. And so I created this switch just to implement opcode reactions for each case. Basically, each case has its own unique opcode. I think that's how the architecture works. Correct me if I'm wrong. I'm just a 14-year-old who's extremely inebriated, drunk, and who isn't too good at programming. So this is the loop I was talking about. I don't know why I was talking about using some other thing except for while. It's pretty dumb of me. But here's the CPU step. looking at it right here, CPU step. So this looks to be an 8-bit byte representing opcode. Opcode, yeah. So opcode is 8-bit, right? Because everything's 8-bit. It manipulates a 16-bit address that the bus provides. And up here, this is the add cycles. So I haven't even mentioned what the step and cycles are for. So the step is to measure each cycle as it occurs. As you see right here, it says int cycles equal base cycles opcode. So this is the base cycles. Let me go back to base cycles. Where is it? I think it's defined up here. No, it's not. Okay, so base cycles doesn't even have a definition for it, so I need to fix that. But int cycles, right, where am I? Hang on. CPU step, int cycles. This right here has a definition, base cycles, and that, concatenates to the opcode. Hang on, why the fuck am I in replace mode? Okay, please go back. Okay, so base cycles right here. This is accessing the array opcode. I'm certain that this works together in unison to find certain opcodes based on the cycle. I'm not completely sure. Like I said, I know nothing about the C programming language. I'm simply experimenting with it as I go. Most of this code wasn't written by me. Well, most of it was based on ideas that I had in the implementation process of the 6502 CPU, but most of the code was written by a large language model, and which I copied back into my Vim editor. Yeah, but I did this just because I know nothing about the C programming language, but most of the implementation here, right? The main idea is set across all of this code, right? So you have the carry flags, or the flags that the CPU calls to, or doesn't call to, but rather represents most opcodes. Or registers, CPU registers. These are the CPU registers. These are the flags that hereby represent the registers. This right here is the read byte and the write byte. These both read byte level memory addresses. It gets its data. It accesses an 8-bit memory, an 8-bit byte from a 16-bit memory address. This right here, the write byte, writes to. Hang on, let me look. Memory, 8-bit memory, like 16-bit address. Okay, so equal value. All right, so the 8-bit. So the 8-bit value is going to be added across whatever memory address it is, but still it's looking at a 16-bit memory address. It's writing an 8-bit memory location to a 16-bit memory address, and it outputs that value. Okay, so, and then the void set flag here is, it points to the CPU. This is an 8-bit flag. It uses a bool condition, so if true or false, basically that's what these represent. So going back to bitwise operations and true or false statements, which are necessary for bit level manipulation of code. Yeah. So void CPU step. This is I think I was just here. Okay. So add cycles and CPU step. This is for adding the cycles so the opcodes know what to do. And the CPU step measures each cycle as the opcode goes along. So basically, for the most part, that's it. I did create this bus. I think that the memory is up here. Yes, the memory is up here. Yeah, so that should be all for now. I'm still working on the opcode implementation and most of the other code up here. like I said, I know nothing about C. Well, I can read C code, with rudimentary precision, but apart from that, I'm not really good at interpreting most of what's here. That's mostly because I haven't been exposed to C for a long time. I do know Python and the other programming languages, so that helps out. But apart from that, I'm a noob, C noob. Although I do know how to use Linux, so yeah, that's about it. Thank you for watching. I will not. It's gonna cut to another part where I go into further detail. That'll be when I discover something new. I think I'm just going to experiment with actually writing my own programs based on the logic I offered to the chatbot in which it provided my code, or to which it provided my code. I'm sorry, I'm just tripping over my words. I'll see you at the next scene.